Thank you very much for coming. I've been really enjoying the conference so far, and it looks like we've got some great stuff. Afterwards, I'm the kind of post-lunch slump, so but be kind. I'm going to talk today about creating a delay. And by delay, I mean this. This is something that will be familiar to anyone who plays guitar. I know there are some guitarists in the audience, which is good. But this is basically an effects unit. So you plug a signal of audio into it, and you take the signal out, and it changes the sound somehow. And this one particularly adds a delay to a thing. And the reason for me talking about this is because there's this thing in browsers called the Web Audio API, which is a way to work with audio using JavaScript. And I think it's been around for ages. I don't think it's being used enough. I want to show people just how simple it is, really. I mean, simple is an awful word to use in a development context because there's going to be quite a bit of code in these slides, but the basic fundamentals are you have a thing, it goes there and makes a sound. So I want people to, if you come away with anything from this talk, I want it to be that. So I'm someone who likes tinkering with CSS, and the GIF that gets passed around of Peter Griffin fighting with some blinds and calling it CSS. I do not agree with that at all. I think CSS is wonderful. I love it. So this here is made entirely with CSS. There's some divs and spans, but otherwise it's an illustration, and that's pretty much what got me my first job in development back in 2013. I managed to show this to someone, and they were like, "Oh, we don't know CSS, but you clearly do." So that's helpful. And I like to tinker every now and again. Shout out to my friend Dan in the corner, who took this little tiny NASA recreation using CSS that I did and made it into a glitch project. So if everyone goes to nasa.glitch.me, they can have some fun with that. I'm also a co-host of a podcast called A Question of Code, co-hosted by Ed, my brother down here, who is learning to code. He's been learning for about a year and a half, and we have brought a microphone with us to the conference today. So if you see us walking around, come and say hi, and we'll record you for posterity. And if you say something interesting, we'll put you on the podcast. No pressure, but everyone so far has been really interesting. So it's nice because we don't have to do so much. Next episode, that's good. I also use the Web Audio API a lot in my open source work. I created Peekabell.js, which is a Node NPM module that you can use to convert vanilla HTML audio buttons into stylable markup that you can touch with CSS. Again, because CSS is awesome. This was a tool I made for myself, kind of leveraging the Web Audio API, and it's kind of a scratch your own niche project. And it turns out that there are dozens of us who want to do this, literally dozens. So it's been very successful. So let's get to the nuts and bolts of how the Web Audio API works. So it's essentially a way of creating sounds and manipulating sounds within JavaScript, and it all hangs around this concept of audio context. So you create an audio context, which is essentially an object that you can then pass around that gives you access to all the audio manipulation functions that the browser has built in. And of course, because we live in the real world, you can't just call it, you have to sometimes prefix things. But this little snippet of code will get you a context that will work in most scenarios. And if you're going home and playing with the Web Audio API after this talk, the one thing I would recommend you do Google is that, because browsers, they change. But what we're going to recreate is essentially what I described with this little pebble here, talking about the signal path. And the idea of the signal path is important when you're sort of setting up instruments to play a performance for people, and it's kind of replicated almost identically within the Web Audio API. So it's the key concept is connecting nodes together. So in this scenario, we have an instrument that creates some sound, a mixer that then changes the volume, sets the volume of that sound, and then some speakers which actually play that sound. And we're going to recreate that pretty much node for node. So we're going to start off using an oscillator, which will create our sound, and a gain node, which is how we control the volume, and context.destination, which is basically the output of whatever machine you're using at any one time. So this is how you create a gain node. So you can see we're using context, and this is all JavaScript, by the way, in case anyone's worried. That little context object in the middle of line 1 there, that's how we access everything. So we're setting up a gain node here with create gain, setting it a value, and then connecting that gain node to the destination. And that is essentially like running a cable from a mixing desk to some speakers. That's what that last line there, that master.connect, is doing. So master is something we've created, context.destination is something that comes from that audio context. So now I'm going to set up a voltage-controlled oscillator. And it's not voltage-controlled, but that's the terminology within analog synthesizers. So that's what I'm kind of using to mirror it here. But on the first line, we're creating ourselves an oscillator with the handy create oscillator function. We're then setting a frequency value to it. In this case, I'm going for 440 hertz, which is concert A, if anyone is musical. And then again, connecting that to our master volume. So in the last slide, we created a master volume control and connected that to the output. And in this slide, we're creating an oscillator and connecting it to that master volume control. So now, brace yourselves. Anyone who likes sine waves is in for a treat. Now we've got that object, we can start it and we can stop it. Ta-da! And it's probably helpful as we're going through to have some sort of sense of how this looks on the frequency graph, just to kind of visualize what we're up to. So the same principle, we're running a drone and we're stopping the drone. And that's just with start and stop, which are functions that come with our oscillator. But that's, it's pretty annoying to, it's going to get boring pretty quick. So what I want to do now is pulse that sound. So rather than having to hit start and hit stop, I want to just start the thing and have it happen. And we do that with a thing called current time. So JavaScript has concept of time built in. There's the date object and there's the parameters you pass to a set interval function. They're a little bit unreliable. The audio context has a thing called current time. It keeps its own time. So you can create loops and you can do all sorts of different things with that. But in this case, we're just saying start now and then in a quarter of a second, stop. Ta-da! But that again is we're still using pretty raw sound. So it's on and then it's off, and it's a little bit gross. So what we can do is we can actually start nesting nodes. So now rather than having my VCO as the top level object, my oscillator, I'm creating just a note object. And in that I'm putting in my oscillator, but then I'm also putting in a gain node. And VCA is voltage controlled amplifier in synth terminology. And then doing the little connect dance, plugging those things in. But that now is one whole unit. And when we start that oscillator, we can then have some control over its volume independent of our master volume. So we can have lots of different nodes all creating audio at the same time, each with their own volume control, which allows us then to use exponential ramp to value at time, which is a snappy function, but essentially it exponentially ramps to a value at a given time. So we say we want to get to value 1, and the time we want it to take is from now until 0.2 of a second. And then the same with stopping it. So we're starting and stopping. So now it's a very subtle difference to what we had before, but it is gently coming in, gently going out. And so we have a little bit more control over that. And to make things a little bit more interesting and perhaps a little more sonorously confusing, perhaps, I've made a little function that will randomly pick a frequency between 220 and 880 hertz. And every time I press it, it will give us a different frequency. So if you're thinking of like programming some kind of sci-fi computer, that's the computer brain working there in the background. But it's a bit gross because it's not musical in any shape or form. So our next slide is basically setting up an object, and the dots there are to indicate that this continues for the length of the scale. But I'm setting up an object with note values for notes that we know in advance. So in this case, it's C major scale. And then using the same random function that I had in the last slide to pick one of those notes at random. So rather than randomly generating a frequency, I'm picking from a preset selection of frequencies, which allows us to have slightly more sonorous pulses. So this one now is where we start building on that idea of having nodes that are connected to each other. So now we're taking our note object and we're spreading that out into a new note object. Any sort of functional programming people will probably not like this code, but bear with it. It's just for concision. I've kind of truncated things a bit. But basically, we're having our note object with our first oscillator and amplitude, and we're just adding a second one to it. And then I've made a little frequency transposing function at the top there, and that sort of picks a new note. It sort of adjusts the note value by a power of 2, which is how kind of very, very simple harmonics work within music. And we're just going down any number of steps that we want. So in this case, I'm going up 7 steps, which is a fifth. So we can get a 2-tone pulse, all with the same note start function that we were using before. And this is where now that we're making a sound, we're putting it through our mixer and outputting it, we can add in our effects loop, which is where this little fella comes in. Yeah, see? Very perfect recreation in CSS, I hope you find it. And what we've got is a delay pedal, and there's handily a way within the Web Audio API to create a delay, and that's called create delay. That's the function on line 1 there, and we're setting it to delay 0.4 of a second. So now we press. Pressing once gets us 2 different values, and the next step is perhaps the scariest, and this is the only bit of non-teal colour in the slide as well, just to emphasise its importance. When you're presenting and you're mic'd up, feedback is the last thing you want, but that's basically where a signal goes in to the same way that it came out, so it goes in twice, basically. So what we're doing is taking the output signal, so that delayed signal from our pedal, and looping that back into the input of the delay, so that it keeps going, kind of a recursive loop there. The important thing to note is don't put all of it back in, because you'll then get feedback, which is where you get that horrible squeaky tone that then eventually blows your speakers. So the important thing is to feed some of the signal back in on itself. And we can do that by basically creating another sort of connection. So playing around with our cables, imaginary cables that are connecting our nodes together. So delay.connect feedback is basically connecting this new feedback node that we've created, which is create gain, same as we did for the master volume, same as we did for the individual volume controls for notes. We're creating now another volume control. So we can say, we want 0.3 of that signal to go wherever this gets connected to. And then we're just connecting it back into the delay. So delay connects to feedback, feedback connects to delay. And the delay can have you can connect nodes to multiple different places, so we're connecting our delay to the master, so we can still hear what happens. But now when we press the pulse, rather than it just repeating once with that delay, we're then reusing that delay. And that's just to reinforce that it's just a question of connections. Imagine, if you're creating these things, imagine it as cables. And this is an instance where the Firefox developer tools are fantastic for this. I'm a Chrome guy normally, but the Firefox dev tools are way ahead on this, and they basically visualize this entire process for you when you're creating nodes, and they show you a block and the connections, as if it were analog machines that you're connecting with cables. So now we can start playing around with that. We've got, essentially, this now. The cable, the buttons on the top of here, the little knobs, we created with nice little faders here. So we can set the values that we want to beat, so we can have a really quick delay, but we can give it a lot of feedback, have it decay an awful lot, and then we can change the different sounds that happen. And then when we've got these controls together, it kind of allows us, I don't know if anyone, show of hands who's familiar with Terry Riley in the audience. We've got 1, 2. Right. You guys are much smarter than everybody else in the room. Terry Riley was a minimalist composer who built a lot of work on repetition of simple patterns. And that was the first thing that came to mind after having sort of plumbed all this in together. I had dreams of this amazing sort of looping system that would be really impressive. I was going to recreate Where the Streets Have No Name by U2 using just the oscillators. But it turns out I've built this in React, this little slideshow, and connecting all those things and making a loop was just too much to do in the time that I had. So I've gone for a Terry Riley approach, and this is just much more. And is essentially a very, very simplistic piece of pretty much procedurally generated music created by the Web Audio API. To summarise, all the code that I wrote for that is available online, and I'm hoping that this will spark people to do things more creative than just that. I think there is a lot of scope with this tool that's been around for a while but doesn't seem to be used very much, mostly because audio from a computer that's unexpected can be quite annoying, but there are plenty of practical applications. If you can generate sounds yourself, and you can generate them procedurally, you can do all sorts of things that you would previously need to sort of call in audio files, actually pull in MP3s and use network requests and use up people's data. You can do that all within the client. And that's basically me.
Questions, if anyone's got any for Tom.
Fellow at the back was first.
Does it plug into Chrome's MIDI API as well, so can you pull in from MIDI keyboards and things like that?
I haven't done it myself, but I believe it can. I think there are functions for you can connect to audio streams that come in, so you can get raw audio from inputs like you would for anything else if you were building a piece of software. And I believe it does play with the MIDI things nicely, but yeah, I take that with a grain of salt. I've never done it myself. But the MDM docs for this are fantastic. They've got everything that you need to know in there. So I bet there's an answer to that question for sure in there. Was one in the corner there?
Kind of say there's a library called Tone.js which extends a lot of the web audio functionality and gives you a lot of oscillators and kind of time handling for free as well, which is possibly quite a good way to kind of explore that as well. But
yeah, I vouch for Tone.js as well. There's a lot of, if you look on CodePen and search for Tone.js, there's loads of really compelling demos there that are much more exciting than the basics that I've put there. My point with this talk is to just kind of show the absolute basics and see that you can have a little bit of fun with just some raw tools. And there was another question just behind you, Martin.
I just wondered about the performance of it. Is it actually implemented in JavaScript underneath? Or
it is, yeah. So this is one of the reasons not to use sort of built-in JavaScript timing functions, because something that is reliant on a set interval to create a loop, for instance, will stop whenever the thread stops, so you don't get accurate sequencing of samples. One way to get around that is to sort of send off to a service worker and have that running in a separate thread. And also, if you can manipulate the context current time value, that is a much more that kind of sets up its own independent thread just for that as well. So there are some performance issues. You start doing loads of things, as with almost anything in JavaScript, eventually it falls over, but there are ways to manipulate that as well. So service workers and node context current time are your friend. That's nice.
But in terms of the actual waveform data flow, that's all done in the browser.
It is, yeah, and I was very skeptical at first, but having played with it around, so what I was using for the visualizer, that little graph there, that's a D3 SVG graph that's put in React, and I'm using something called an analyzer node that comes with the Web Audio API that basically just gives you set your sample rate as if you were sort of building an MP3 file or something. You can set your bit rate and frequency and everything, and then it will give you, for each bit, it will give you an array of frequency values at the kind of specificity that you ask it to. And so you basically just get these massive, great big chunks of data. So that graph there is whatever is coming out of the audio channel is getting just converted into a whole massive arrays. And it's all numbers, which is what computers eat for lunch. And yeah, it works. I've never had any problems with that. I was really skeptical at the start, but it turned out to be quite good. How are we doing? Any more questions? Or?
Do one more question?
Someone has to think of one now.
Okay. Did you have any problems when you were first looking at web audio in terms of support between Chrome and Firefox?
Yes, yeah, very much so. Certainly back when I first sort of made my first little keyboard with oscillators, that was probably 2014, I think. It was the Wild West. There was not much in the way of documentation, and because of that, as it's evolved slowly, now it's pretty robust. So there's a lot of well-documented support, and I think as we sort of ascend to the monoculture of one browser, that makes that easier as well. But the documentation has got much better. But it does mean that there are a lot of articles and blogs written from a few years ago that are now sadly out of date. So all the things that I built in the first couple of years with the Web Audio API stopped suddenly working as demos because someone in the spec decided that actually auto-playing audio is horrible, quite rightly, I think. but all of my things kind of relied on setting up a whole load of oscillators at the very start and then controlling them with gain nodes. And so that's changed now. You have to actually have your audio process has to be started manually by some kind of interaction. So there are occasional changes, but it is solidifying now, and it seems to be much more well supported standards-wise.
Perfect. Thank you so much, Ron.